electrochemistry. So here, what is electrochemistry? So electrochemistry is a branch of a chemistry, so which is deals with the interactions which is present in between the electrical energy and chemical energies or chemical changes. So mainly it deals with what interactions between the electrical energy to chemical energy to electrical energy. So here, what is mean by electrical conductors? Electrical conductor. So electrical conductors are the substances which allow the electrical current, current. That substance are known as electrical conductors. So majorly these electrical conductors are divided into two types. So first one is metallic conductors and second one is electrolytic conductors. So depending upon how they produce the electricity. So let's see one by one. So first one, metallic conductors. So these are also known as electronic conductors. So what is mean by metallic conductors? So these are the conductors. See this one. These are the conductors which conduct the electricity without undergoing any chemical changes. There is no change in the chemically, but they will show the electricity. So how can they show the electricity? So this is because of every metal consisting with the electrons. So due to presence of electrons in the metals, they will show the electricity. See this one. In the metallic conductors, flow of electrons. So because of this flow of electrons, then only they will show the electricity. So for example, copper, iron, aluminum, so like that, etc. And these are the best example for the metallic conductors. So next, second one, that is electrolytic conductors. So these are also known as electrolyte. So let's see what is meant by electrolytic conductors. So these are the conductors which undergo, see this, which undergo decomposition. After decomposition, then what happen? They will release the ions. That means they undergo chemical change. By going in the chemical change, then only they will show the conductivity. So remember this one. So these are the conductors which undergo decompositions. So when the electric current is passed through them, that means they undergo chemical change. So what happen after the passing the electric current through the this type of solutions? They will release the ions. So due to presence of ions, then only it is possible to flow of electricity in the electrolytes. So for example, solutions of acids, bases and salts in water. So these are the best example for the electrolytic conductors. Strong electrolytes. So what are strong electrolytes? Strong electrolytes are the substances that only exist as ions in solutions. That means they completely dissociate into their ions when dissolved in a solution. So next one, weak electrolytes. So what are weak electrolytes? Weak electrolytes means a weak electrolyte only partially, see this one, when they partially dissociate in a solution and produce the relative few of ions. They partially dissociate, that means they not completely dissociate, but they only partially dissociate in a solution and produce its respective few of ions. So and next one, conductancy or conductivity. So this is indicated with the capital C. So how can you define the conductancy? So here we can easily define the conductancy, the reciprocal of the electrical resistance. The reciprocal of the electrical resistance is known as conductancy or conductivity. Simply see this one, conductancy C is equal the reciprocal of resistance, means 1 by R. See this one, this is 1 by R. C is equal to 1 by R. So this is known as conductancy. So coming to the units, so what are the units for the conductancy? So here conductance or current C is equal to, what is the formula? C is equal to 1 by R. 1 by R. R means, where R means resistance. So what are the units for the resistance? We know that ohms, that means 1 by ohms. If you take it upside, then what happens? Ohm inverse. You can write it ohm inverse like mho. Ohm inverse is also equal to mho. Next one, so that is specific conductance. Specific conductance, or it is known as electrolytic conductivity. So another name for the specific conductance, it is electrical conductivity. So it is denoted with the K. Here K means kappa. So how can you define the specific conductancy? So before going to define the specific conductancy, so we have to know the what is specific resistance. So after knowing the specific resistance, then only you can easily define the specific conductancy. So before going to that, what you are going to know? You are going to know about the specific resistance. So let's see what is specific resistance. So for this, yes, here the resistance is the resistance or the resistance of any conductor. It is directly proportional to the length. It is directly proportional to the length, and also it is inversely proportional to the its area of the cross section. So that's A. So what is that? You can write it as the resistance of any conductor, or it is, what is the first condition? The resistance of any conductor, it is directly proportional to the its length, that means L. And second one, or it is indirectly proportional to the its area of cross sections. So indirectly proportional to the area of its cross section, that is 1 by A. So by using these two equations, you can write it as, or it is proportional to L, indirectly proportional to A, or is proportional to L by A. If you remove the proportionality, then you can keep the one constant, that is proportionality constant. So here it is, or is equal to, so some constant, here it is known as a rho L by A. So write down the equation for the rho. Rho is equal to R A by L. Rho is equal to A by L. So where here is a rho means, it is known as specific resistance. Rho means specific resistance. So what is the equation for the rho? Rho is equal to R A by L, where rho is equal to the proportionality constant, it is called as the specific resistance or resistivity. R means resistance, A means cross section area, L means length. Okay, then what are the units for the rho? You know that what is the equation for the rho? Rho is equal to R into A by L. See this one here, it is the one correction, that is A by L. See, rho is equal to R into A by L. Here what is the R? R means resistance. See, what are the units for the resistance? Ohm, you know very well, ohm. A means it is the area. What are the units for the area? Centimeter square. If you take in centimeter, then it is the centimeter square. And what is the L? L means length. What are the units for the length? That is a centimeter. So substitute all the units in this equation, then you can get the ohm into centimeter square by centimeter. Here 1 centimeter in this 1 centimeter is cancelled, so remaining what are the ohm into centimeter. So what are the units for the rho? Rho means specific resistance. Rho, what are the units? Rho is equal to ohm into centimeter. Ohm into centimeter. So this is the units for the specific resistance. So by using this specific resistance, then you can easily define the specific conductance. So how can you define it? Then the specific conductance, it is defined as the reciprocal of the resistivity or specific resistance is known as specific conductance. What is the specific conductance? Specific conductance means is the reciprocal of specific resistance is known as specific conductance. Here specific conductance is denoted with the K. K means kappa. So how can you write this? K is equal to what? K is equal to the reciprocal of the specific resistance is known as specific conductance. What is the specific resistivity or specific resistivity? It is denoted with the rho. K is equal to 1 by rho. See this one. This is the K is equal to 1 by rho. Then what are the units for the specific conductance? What is the equation for the specific conductance? K is equal to 1 by rho. What are the units for the rho? You know very well that ohm into centimeter. So take it upside, then what happened? Ohm inverse and centimeter inverse. How can you write ohm inverse? You can write it ohm inverse as mho. Then finally you can get the units for the specific conductance. So what is that? Mho centimeter inverse. So these are the units for the specific conductance.